So thank you very much, Ananish Chaudhuri and everybody for joining this talk. Ananish is a professor in experimental economics at the University of Auckland and also the head of department there. And someone very close to me, he was my advisor, PhD advisor, master and honor advisor also. So today's talk will be, what's the topic today? On piece rates, salaries and tournaments, economics and psychological competition in real effort tasks.
Okay.
All yours.
Sawadee krap. Thank you so much for having me here. Very nice of you to show up. And let me tell you something I'm working on. And yes, it's a real pleasure to be here to see Meg in her workplace. So I'll get started. So let me start by telling you what this is about. So the basic question here is, how should you pay someone? So often we pay people on the basis of what we call piece rates. Right? What's a piece rate? A piece rate is I'll pay you based on your output. Right? So number of cars you have sold, or the number of hours you have put in, etc. Or very often we pay people a salary. It's a fixed salary. The important point is that when I say salary, that means this is independent of performance, right? And which in turn suggests that under a salary, if I know that I'm going to be paid a fixed amount, at least according to economists, you don't have a lot of extrinsic incentive to perform. So regardless of how you do, you will get paid a fixed amount. So economists typically believe that in those cases, you probably won't work very hard. And then, a lot of our pay structures are based on what I will refer to as a tournament. Now, what's a tournament? A tournament means that, first of all, your pay is based on relative performance. Let's look at these for a while. Now, obviously, most payment schemes are sort of combinations of these things. They're not really one or the other. For instance, if you look at car salesmen have a small basic salary and then they earn commission on top of that. For instance, my salary is a fixed salary, but I do have a little bit of a bonus on top of that. So most payment schemes are a combination of these, but to avoid making things too complicated, I'm going to think about these as separate ways of paying. So here are the basic distinctions. If I say that I will pay Meg does something, right? She sells cars, and I will pay her based on her performance. So her payment will depend on how many cars she sells, right? So that's typically, I will call that a piece rate. Some people might refer to that as a commission, etc. So there may be a small base salary, but then much of the salary depends on how many cars you have sold or how many houses you have sold, right? This is typically how we pay people like car salesmen, real estate agents, etc. Salary, which is a lot of bureaucrats, right? A lot of people in the bureaucracy get paid a fixed salary where your pay is independent of performance. So even if you, as long as you come to work, sign your name, and then you hang your coat on your chair, and then you take long tea and lunch breaks, you still get the same salary at the end of the day, right? So I don't know about Thailand, but this is certainly true of India, right? The jacket is there on the chair, but the person is often not there. And finally then, tournaments, what I will call tournaments, your pay now is based on relative performance. So it depends on performance, but it depends on performance with respect to others in the group. So what's an example of this? Example is many sales teams, for instance, will have commissions based on being the top performing sales team. Right? So if you're the top performer, you get a bonus, or you get the vacation in Hawaii. Right? Within these kind of payment schemes, there are basically two types. One of those is sometimes called a winner-take-all. Now, these are sort of shorthand terms for things that happen, right? Winner-take-all simply means that the person who wins gets the payoff, the other person doesn't. On the other hand, you can have a slightly different one, which is a version of winner-take-all. It's called rank order. Rank order simply means that how much you get paid depends on what your rank is. So the top person gets paid a large bonus, the second person a little bit less, etc. So if you think about ways of paying people, these are the basic ways we pay people. Again, understanding that it's really a combination of some of these things. But the question is, what kinds of incentives do we provide when we pay people this way? And more importantly, what payment scheme should you use? And depending on what kind of work people do for you, etc. So that's what I want to talk about. So please stop me if you have any questions or anything. Okay. Now, this is not new. There's a huge amount of work looking at these kinds of things, right? And I'm going to skip most of that. There's a fair amount of experimental work in this area, starting with this famous paper by Bull, Schotter, and Weigler. Schotter was one of my PhD advisors who wrote this famous paper called Piece Rates and Tournaments. So the idea here is based somewhat on that. That was a while ago. And if you find this interesting, there are two surveys available, the one by Kenichi Pendergast. That's mostly a survey of the field study type of work, and then this is unpublished on experimental work in this area. Okay. Now, before I go on, let me say a few things, right? So economists, by and large, believe that the only way you can get people to perform is if you explicitly incentivize that performance. So Meg will sell more cars if she gets paid more to sell more cars. But psychologists, by and large, don't believe that. Psychologists believe that we work hard because we want to work hard. Right? Psychologists have a name for this. They call this intrinsic motivation. Intrinsic motivation says that we derive pleasure from doing a good job, and therefore we do a good job not because of the money, but because of the pleasure of doing a good job, which means that even if my payment is not dependent on my performance, I will still do a good job. So in some senses, we are going to try and address these kinds of questions in this week. So one difference then is, does pay depend on performance or not? And then if pay depends on performance, then we can think of two ways pay depends on performance. Is it your absolute performance that matters? Does it matter as to how you do? Or does it matter as to how you do vis-a-vis others in your company? So tournaments and piece rates, or what I call it tournaments and piece rates, then both pay you based on performance. But there are some differences between these, right? So again, let's take Meg. So Meg can be paid in one of two different ways. One, she can be paid based on how many cars she sells. That's absolute performance. Or I can say, I will pay you based on whether you have done better or worse than others in you. That's a different incentive. When we do this, there are a few different ways in which these incentives differ. The first way this differs, and this is, I think, one of the value added of our paper, is one way this incentive differs is by changing what we call the notion of psychological competition. What does that mean? Well, that means if Meg is competing against me and her relative performance differs, then that might matter because she might simply get pleasure from winning or pain from losing. Right? So when we tell her that your relative performance matters, it's not so much the money, but the pleasure or pain of winning and losing that matters. Right? So she might care whether she's winning or losing, even if that doesn't matter for money because we do that all the time, right? I mean, we play competitively. You probably go out and play golf on the weekends, and you take pleasure from beating the other people, right? Even if it doesn't give you any extra dollars, you still like it, right?
Gives me $2 a hole.
So we might care about that aspect of it, but also if my performance matters for my payoff, then I also care about doing better because bad performance or bad decisions mean bad payoffs. And then there's one other aspect to this kind of tournament type payoff schemes is the information. Now when Meg is working in her office or when Meg is selling cars, she certainly knows what she has done, but typically she doesn't know what others are doing. But when you tell her that, oh, you know, you did this, on average this is better than everyone else, or on average, or this is better than the average, this is worse than the average, or you're in the top 10%, that gives her more information about how she is doing. And more importantly, she also now knows that it's possible to do a lot better or a lot worse. Right? So these things matter, and while we are looking at this in the context of purely payment schemes, much of this is now finding a lot of application. For instance, there's a lot of work on trying to get students to do better. And a lot of that kind of work, the people who do that kind of work use these ideas. For instance, increasingly a lot of people are looking at, well, people are looking at whether you can just pay people to do better. Right? And they're also looking at, does it matter that you are doing better than others or worse than others? And I can tell you, I don't know if you're interested to know, but I can tell you the answer to whether you should pay people. And the answer is yes or no. If you want people to do better in math, you can pay them. But if you want people to do better in English, paying is not going to make any difference whatsoever. So it turns out that if the task is well defined, or if the task is somewhat mathematical in nature, explicit payoffs can actually make a difference. But if the task is less well defined and the answers are not very clear cut, in fact, one of the studies that looks at paying people by Roland Fryer at Harvard and one of his collaborators who's now at UNSW. So they took these sort of 50 schools in the Houston school district and they paid these kids for their school performance. And what they found was that when they were paid, their mathematical performance went up, but their English and reading performance went down. Right? So all these things have some significant effects on how people respond to these incentives. Okay. So what we are going to do then is we're going to look at performance in a task, and we're going to pay people differently using these different schemes. And we're going to use what we will call a real effort task. Now, a lot of experiments in economics, I don't know how familiar you are, basically ask you to enter numbers in a keyboard. But increasingly, we are using more and more challenging tasks. For instance, I might say, well, go and raise money for a charity, or catalog library books. So get people to do something that requires what's called real effort. So you have to put in some effort. So our task doesn't require real physical effort, but it requires real cognitive effort. So you have to think very hard about this problem. So it's cognitively quite challenging. And what's the task? I'll tell you in a minute. So you need to expend effort to perform this task. So the task that we used, and this is taken from some work done by my co-author Paul Brown before, is called a multiple Q probabilistic learning task. It's a very long name, but it simply means the following. So what will happen is if this gentleman is playing my game, so he comes in and he sits down and we give him the instructions, and then, so this is all framed. The instructions frame this as if you are trying to predict the value of a stock. Now, as we all know, you can't exactly predict the value of a stock, right? But you can look for market cues that might tell you something about the stock. So what this is saying is, I'm going to give you two values, A and B. And based on the values of A and B, I'll ask you to predict the value of this stock. And here's the relationship. The relationship is the actual price is 10 plus 0.3 times the value of A plus 0.7 times the value of B plus a small error term. Right? That's the relationship. Now, clearly, this is not very easy. This is a difficult relationship. And the other problem is that you don't know, or he doesn't know that this is a linear relationship. It could be anything. All he knows is that he's looking at two values, A and B. To start out, and I'll say this again shortly, I'll give you some examples. I'll give him some examples to look at so he can kind of fiddle around for 5 or 10 minutes trying to figure out what the relationship may be. And then once the game starts, every round he will see a key A value, a B value, and then I'll say, okay, what's the prediction of B? So the idea here is that you are not going to get this right. This is very difficult. So you're not going to get this right, but the question is how close can you come to the actual value? So it's as if I have given you a bullseye, and I'm saying throw a dot at the bullseye, and your aim is to come as close as possible. Now there are two assumptions underneath. One is that if you think long and hard about this problem, then you should get closer to the problem. Right? If you think long and hard, you should be able to come closer to the answer. And the second assumption is that the way I pay you will have an impact on how long and hard you think about the problem. Right? The payment scheme should have an impact, hopefully. So again, so the relationship doesn't change. This is, you'll play for many rounds. This is relationship. Every round you get to see an A value and a B value, and you're trying to predict P, and then you get to see, I'll tell you a few things in a minute, and then I'll stop and see if you have any questions. So the relationship is unchanged, but the Q values are going to change every round. You're going to play for 20 rounds. Every round the A and B will change. What's the metric of good decision? The metric of good decision is your forecasting error. How close are you to the actual value? Right? So just to go back. So suppose A is 10, B is 100. If A is 10, then 0.3 times QA is 3. If B is 100, 0.7 is 70. So you have 73 plus 10, 83, plus a very small error term. Let's ignore that. So the correct value, if A is 10 and B is 100, then the correct value here is 83. Clearly you're not going to get that. But the question is, can you come close to 83? Or how close are you to 83? And then my measure of your performance is the difference. So if you are 80, then the absolute difference is 3. If your prediction is 10, then the absolute error is 73. If your prediction is 50, then the absolute error is 33, etc. So that's my measure. And what I want to look at is, does that gap between the actual value and the predicted value decrease over time for me? That's the basic question. So that's our measure of performance. That are you getting closer and closer to the actual value over time? All right? Let me just pause for a minute. Is everyone reasonably clear about the game? So this is the game, or the task that you have to do. Okay. So what happens is, have you guys seen experiments? So I have a computer lab. So you come into this lab. There are 32 machines. Each machine is there's a cubicle around you. You sit down, and we'll give you the instructions, and you get $5 just for showing up on time. And then we read the instructions, and then we'll give you 5 minutes or so to look at a series of examples, just to give you an idea of what the relationship might be. You get to see some examples. So that's your information to try and work out what the relationship may be, and then we'll say, okay, time's up. We'll start the experiment now. And so in round 1, what will happen is you'll see 2 Q values, A and B, and then you'll have to enter your prediction for that round. So once you enter the prediction, then you will get to see what happened, how much your error was, and how much money you earned. and then you'll get the second Q value for the second round, and so on for 20 rounds. Okay. Now, how do you earn money? Here's how you earn money. Now, we're going to have different treatments, but they're all based on these payment schemes. So one payment scheme, which I will call a piece rate, is this. So every round you have $1, and from your $1, I'm going to subtract your absolute error. So if your absolute error is 10, you get 90 cents. If your absolute error is 50, you get 50 cents. This is actual dollars and cents. If your actual error is more than 100, then you get nothing for this one. Then we are going to have a very rudimentary form of tournament, which is a two-person tournament. How does that work? Well, that works the following way. So this gentleman, he's going to be paired with one of you every round. So you don't know who you're paired with, but he knows that he's paired with someone this round and somebody else next round, somebody else that round, etc., etc. So in round one, if he's paired with Ming, then we will look at whose error was bigger. If his error is bigger, then he gets nothing. Meg gets $1. If his error is smaller, then he gets $1, Meg gets nothing. So this is a very sort of kind of simplified version of a tournament which says that the winner gets everything. It's not a big deal because you can make this graduate. You can say groups of 4, first person gets this, second person gets this. I don't think that's a huge issue. It may be, but this is a very simple tournament which says if you win, you get $1. If you don't, you get nothing. And then finally, because psychologists say none of these things should matter, we tell them that, you know what, you're going to come in, you're going to play this game, and here are the instructions, and your job is to minimize the error, but at the end of 20 rounds, you will get paid $20. It doesn't matter what your errors are, it doesn't matter how you did. If you play for all 20 rounds, you will walk out with $20. It doesn't depend on your performance. So this is a test of pure intrinsic motivation. Do you do a good job even if your performance doesn't matter for me? Okay. Then we look at a whole bunch of different treatments. I'll take you through this. So we have something called piece rate. Here, what that means is that you're getting $1 minus your error every round. Maybe I'll skip this slide and then I'll go to the next one so that I'll take you through the treatments. So what's a piece rate? A piece rate, just as I said, is you have $1 every round, and you will lose your error. So every round, I will take away your error from that round. So if your error is 20, you'll make 80 cents in this round. Then we have something that we call win-lose. Now, what's going to happen is, for reasons I'll explain shortly, you are going to play the same way for the first 5 rounds. Everyone will play the same piece rate for the first 5 rounds. The first 5 rounds, your payment depends on your performance. It's $1 minus your error. Then, from 6 to 20, for the next 15 rounds, now I'm going to start assigning you a partner. So every round you're paired with someone. And what's going to happen is this. Your earnings are still the same. So you still earn $1 minus your error, but now every round I'm simply going to tell you whether you won or lost that round. Was your error bigger or smaller? Right? So this is, remember what I said before, that when you change from paying someone based on absolute performance, relative performance, you have changed 3 different things. One is the payoff, second is whether you're winning or losing, and third is how possible is it to do better or worse. So when we go to this treatment, what we have changed is your earnings are still the same. Only your absolute performance matters, but you now have information as to whether you're doing better or worse than someone else. So this is the pleasure, this is your pleasure of winning or losing at golf. Doesn't matter for your payoff, but the psychological boost from knowing I did better or I beat the other person. Then we have something that is called tournament. Again, the first 5 rounds are the exact same thing. And then from round 6 onwards, we're going to assign you a partner. And now you will learn, at the end of each round, you will learn how well or how badly you did, whether you won or lost, and now your payment will depend on whether you won or lost. So you either get $1 or 4 or nothing. And so we provide people a little bit of extra money because it is possible that you will earn nothing from this round onwards, right? Because if you lose every round, you won't get any more money. Okay. Then we have a treatment, and I'm going to talk about this because it doesn't make any difference whatsoever from tournament. But you play the tournament type payoff. So you're playing with somebody else, you know you're winning or losing, but you just don't get to see any of the information. There is no feedback on how you did. So you know that you're playing a tournament. Excuse me. But you are just not learning that every round. So the question then is does it matter whether I learn whether I'm winning or losing every round, or I know I'm winning or losing, but I just don't get to see it till the end of the round, or till the end of the second. Then we have a salary, where you get $20, nothing regardless. So what happens here in the salary is on the screen, you get to see what your error is and what you would have earned, but you are told that doesn't matter, you will get $20 at the end of the session. And then we also looked at a treatment, and this is one of the surprises. We also looked at what happens if suppose you paid your bureaucrats a fixed salary, but you tell them whether they're doing better or worse than others. So you provide them some feedback. They get the salary, but you tell them, you know what, you did far worse than the other person. Will that make a difference? So these are all our different treatments. Okay, so now let me take you through some of our results. So here are the questions then, right? The question is, when you pay people for performance, do they care more about the money, or do they care more about winning or losing? And the answer is, you could look at a scheme that pays them on the basis of only their absolute performance, and then what we call win-lose, which says, well, your payment hasn't changed, but I'll tell you whether you won or lost. Because here the incentives are the same, but we have changed the information that you get. Or is it the payoffs that are more important? You care more about the money than you care about winning or losing. So do you care more about status or more about money? Now, if you care more about money, then I can compare win-lose versus tournament, because in win-lose, you excuse me. In win-lose, you get the same piece rate payments, but you get to know whether you won or lost. And in tournament, you get to know whether you won or lost, but you now also get $1 or nothing based on whether you won or lost. So you can say. Is information in tournaments important? So suppose you put your sales force on a tournament type thing. Does it matter whether they get feedback constantly or at the very end? And I'll tell you the answer, it doesn't matter at all. The extra information doesn't matter. The performance here is not different from the tournament. So I'm going to skip most of this. Excuse me. Finally, the question of extrinsic versus intrinsic motivation. So does it matter that your payment depends on performance or not? Most economists would say that yes, right? If you're economists, they'll say that you must pay people based on their performance, otherwise they will never do any work. And finally, as I said, if you use a salary, does this information about how you're doing matter? So these are the kinds of questions. I'll take you through all of these in a minute, so you'll see what the basic results are. Along the way, we also have some data on gender, and then we also looked at these kinds of things. Before we started the game, we used a psychological questionnaire to measure what's called trait anxiety, which is how anxious you tend to feel in these kinds of situations, because that might have an impact, right? Because the problem is a bit challenging. If you tend to get very anxious, you may do worse, etc. And then following the task, we also asked them how motivated they felt, how much effort they put in, how competent they felt, and how interested they felt in this task. So these are all sort of standard psychological questionnaires that we use. And just to tell you, I don't have a lot of results in terms of these, so I won't say all that much about this. Okay. So we have 376 subjects, and we have 2 different experiments. So the first experiment is what I just explained to you all this time, which is, you have 2 values, A and B, and you have to predict a price, P, etc. So that's experiment 1. Experiment 2, we made the task easier. Because the first task is actually quite challenging, and the Q values are far apart. So what happens is, sooner or later, people begin to figure out, they sort of assume that it's linear. And they begin to figure out, well, it's sort of a combination of A and B. So maybe it's half and half or something, right? So we keep trying various things. But when the Q values are far apart, for instance, if QA is 1, there's one example where QA is 1 and QB is 399. Even if you think it's half and half, you're still going to be very far away from the actual value. So the first game is quite difficult. So then we say, well, how about we make the game, make the task a little easier? So the second task, what we said is that, you know what, QA is always 150. So all that changes is QB. So now it's easier because all you're trying to predict is a relationship involving one variable in some sense. Right? So we wanted to see if that made a difference, and I'll say a few things about that. Okay. Right here is my basic result. So of all these treatments, the 2 highlighted rows are the ones which did the best. Again, what do I mean by that? Well, what's my measure? My measure is average error. And the smaller that average error, the better you did. So if you aggregate over all subjects, etc., here are the 2 treatments that did the best. A treatment that we call win-lose, and at least surprising the economists, salary. Average errors are smallest in the salary treatment and in the win-lose treatment. Salary treatment pays people a fixed amount regardless of what they do, $20. Win-lose pays people $1 minus your error, but it also tells you whether you won or lost. In terms of average errors, tournaments do far worse. A tournament type payment scheme does far worse if you are focusing on average errors. So that's your answer. In some senses, this is the answer. If you assume the validity of this task, and obviously this is task dependent, but if you think that this is a difficult enough task that might be interesting to look at, and you wanted to pay people, here is the answer basically. If you want to pay on the basis of performance, then pay them something which pays them P straight, but tells them whether they did better or worse. Or you could simply pay a salary, flat fee, and they'll still do very well because they find it challenging enough to do the task. Okay. Let me go on. I'm going to skip all of this. These are graphs showing various things. Let me go to this. Sorry, this is a bit small, but I'll take you through. So what we're doing here, you can look in your handouts rather than on the screen. What we're doing here is I have 4 different models. And we are going to use the P-straight scheme. These are random effects regressions, where the dependent variable is the absolute forecast error. And what we're looking for is smaller errors. So we want sort of negative signs and some of these things. I'll tell you in a minute. So the piece rate treatment is the reference category, and then we have dummies for win-lose, tournament, salary win-lose. We control for the Q spread because, I'll just back up to this for a minute. So you will notice that these are the errors, and there are these spikes. So the errors jump up when the Qs are far apart. When the Qs are closer together, the errors jump down. The broken lines are when both the Q values are changing. The solid lines are when only one Q value is changing. So obviously when one Q value is changing, the problem is easier, so the errors are smaller. As you can see here, errors on average somewhere around 10. Here the error is on average somewhere around 25 or 30, etc. Right? But remember, the sequence of Q values is always the same across all treatments. But when the Q values are closer, the errors drop. When the Q values are very far away, the errors jump up. Which is why these spikes happen almost at the same level for all these graphs. Okay. So what do we find? What we find is that, so models 1 and 2, there's not a whole lot, but if you look at model 3 and 4, in model 3 and 4, we have controlled for the treatment dummies, we control for the anxiety level, we control for female. One thing that's clear here is that women find this task very difficult. They do much worse, which is not that surprising for two reasons. One is that there's sort of evidence that women tend to do worse in mathematical tasks. That's fairly commonplace. It's also possible that women feel more anxious in these tasks. I don't want to say a whole lot because that's a whole different question. But if you look at models 3 and 4, and then in model 4, we also look at treatment round interaction. So not only do we look at what happens across these treatments, but what happens across these treatments over time. I'll get to this shortly. But if you look at these two models, you will find that piece rate win-lose and salary are both negative and significant. So on average, the errors are smaller in piece rate win-lose and salary. All right. Now, obviously, these coefficients are telling you what is true vis-a-vis the base category, which is piece rate. So this is saying that win-lose errors are smaller than piece rate, salary errors are smaller than piece rate. So then, if you want to look across these treatments, you can look at the wall tests, which compares these dummies. And if you look at that, this is saying, is piece rate win-lose different from piece rate? Yes. Is piece rate win-lose different from tournament? Yes. Is piece rate win-lose different from salary? No. Is salary different from piece rate? Yes. Is salary different from salary win-loss? Yes. And this is the part I'll get to at the end. So salary win-loss, when you pay a fixed salary, but you tell people whether they won or lost, does far worse than actual salary. And I don't have a very good explanation, but I'll try and talk about that a little bit. Right, so that's our basic insight, that the win-lose information makes a difference, or does get people to do better, and salary gets people to do better. Okay. Let me skip this. This is just broken up by. This is what happens in experiment 1, experiment 2. I'm going to skip that. Okay. Now the question then, and if you want to thinking, is, so most economists believe that tournaments are a very good way of motivating people. If you really want to provide strong incentives, you want to make people compete with one another. This is true of this is a general feeling. I don't know again about Thailand, but in hospitals, for instance, increasingly we are paying doctors based on various things, right? How cost effective are they, right? And a lot of these things are putting people in these relative ranks. Are you better than others, or are you worse than others, right? And the intrinsic, or our assumption here is that this kind of tournament type schemes where I'm competing with others gets me to perform better. Right? That's a fundamental assumption. That is certainly not true in this case. Tournaments do not do well in general. Now again, obviously this will depend crucially on your task. But if you assume that the task that we have defined, a somewhat ambiguous task which is hard to get at, that requires you to think long and hard about this problem, if you assume the task has any meaning, then tournaments certainly don't do very well. The question then is, why don't tournaments do very well? Turns out that because not everyone in the room are the same. Some of them are actually reasonably good at this task. Some of them are really bad at this task. Some of them get the problem, some of them don't. Turns out that those who are good at the task, those who are able to figure out an answer, do about the same in all treatments. But those who are bad at the task do really badly in the tournament. So if you are not able to get the answer, you will do very badly in a tournament type setup. And you will do better with a win-lose or salary type setup. And here's the evidence for that. Now, what do I mean by good or bad? Right? Now, what helped me here is, remember, what I did was I had everyone play the same treatment for the first 5 rounds. So the first 5 rounds, everyone did the exact same thing. You made a prediction, and then you earned $1 minus your error. So in every treatment, I have 5 rounds, which are the same across all treatments, which means I can use the first 5 rounds to split people up. Right? How do I split them up? Well, there are 2 ways of splitting them up. One is you can say, well, what was the average error in the first 5 rounds? And then let's look at people who are above the average, below the average. Or what psychologists do is they ask, what was the median error in the first 5 rounds? What was the median? Let's look at above the median and below the median. So what we're going to do then is we're going to use either the mean or the median, and we're going to say, well, if you did worse, then you are a low performer, you're not good at this task. If you are below, then you're a high performer. Now, turns out it actually does make a difference here, because here's what the distribution looks like. So the distribution, not surprisingly, has a very long right tail. And the median, and therefore, this is not a normal distribution, and the mean and the median are different. So what happens is the median in this kind of distribution, I guess right skewed, the median is much smaller than the mean in these distributions. So that makes a difference. But anyway, I'll show you both results. So, as I said, I'm going to skip this because the high performers, so suppose you take either the mean or the median, so you're looking at people on the left and the right. So we can just look at the aggregate data. So if that's the median somewhere there, then you're looking at people below or above, and the mean is somewhere around there. So people who are good at the task, they performed about the same in all the treatments. But here's what happened with the low performers. This is people who did worse in the first 5 rounds. And if you notice, you will see that once again, these people do significantly better with a salary and win-lose than under tournament scheme. This is the regression. The regression for the high performers. Nothing is really significant. In fact, the high performers are slightly worse here, but there's nothing much significant going on here. But here, the low performers, the ones who were not very good, do worse in a tournament type setting. And the results are somewhat similar with the median split. If you split by median, again, high performers, nothing is significant. And the low performers do better with win-lose and salary. Sort of. Okay, I'm coming to the end of my time. So the answer then seems to be that if you are good at this task, it doesn't seem to make a big difference. But if the people you're working with, if your worker pool is significantly heterogeneous in their skill level, then putting all of them into a tournament type scheme is not going to minimize your average errors, if that's what you're care about. Okay. So if you think about this as hospitals, and you measure mistakes made by doctors and nurses, and you put all of them into this relative performance scheme, that is probably not the best thing to do. Okay? All right. So, at this point, it appears that overall, tournaments do not do so well. So it's probably don't want to put everyone in a tournament type payoff scheme. But one question you can ask, I'm going to ask two questions. One is, do tournaments perform better if the task is easier? So when the task is quite difficult, tournaments don't seem to do very well. But what if the task is something really menial? Filling envelopes, right? Digging holes. Something that really doesn't require a lot of cognitive ability. And it's very easy to do, the output is easy to measure, etc., etc. What we can do here, you can look at various different things. What I'm going to look at here is the following. And this is just one way to get at it. And I'm going to do this for only one pair. Let's look at the errors committed by the subjects we'll just compare win-lose and the tournament. So there's two different treatments. What we're looking at here is we're looking at the difference in the errors. So the red line is saying what was the average error in win-lose minus the average error in tournament. The red line is tracking what happened in the dual key or the hard task. In the hard task, the tournament errors are much larger, which is why you have a lot of these. This is 0, this is plus, this is minus. So the tournament errors are much larger than the win-lose errors in the hard task. So tournament people on average are doing far worse. When you make the task easier, tournament is not doing so badly after all. So this is not a good answer. But one answer then is, if the task is not very challenging, then maybe a tournament type payment scheme is not too bad. So if it's just kind of punching keys on a keyboard or something, then maybe this kind of incentive works well. But if the task is hard enough, then a tournament type payment scheme may not be very good. The other question you can ask is the following. Given that this is a hard task, did these people learn to do better over time? Because you can ask two different questions here. So again, I'll go back to your hospital example, for instance. If you're measuring errors, what is it that you care about? Do you only care about the average errors people commit? Could be that you want to minimize the average errors. Or you could ask yourself, well, I care about the average error, but I also care about the average error going down over time. I want to minimize the errors over time. That's a slightly different question, which goes to the question of whether did these people learn to get better over time. Okay? We can answer this question. Remember, when I showed you the first regression, I dropped out. In my first regression on some slides ago, I didn't have the interaction terms. But now, I've thrown in those interaction terms. Now let's look at the interaction terms. Okay, now I need to say something. So here, what we're looking at is what happened to the errors in various treatments over time. Right? Okay. Let me tell you the first result. The first result is this, that in tournaments, the errors went down over time. That's not true of the other treatments, and that's only true for rounds 11 to 20. Now I have to say one thing here. Now remember that in a tournament, like most of these setups, the treatment or the payment scheme changes only at the start of round 6. This is a typo, sorry, this should say round 6 to 20. Because before round 6, everybody gets paid on the basis of a piece rate payment scheme. Right? So when I look at what happens from round 6 onwards, I don't get much. But now if I look at 11 to 20, now people have had another 5 rounds of learning. And I find that the errors are decreasing over time in tournaments. But what that means is the errors were larger and they're getting smaller over time. Here's the more interesting finding. The more interesting finding is what happens if I break it up by the high performers and the low performers. The low performers show no evidence of learning over time. They just keep doing what they're doing. But the high performers are learning a lot more in the tournament type setup. The ones who are good at this task are rapidly getting better, but only in a relative performance type payoff scheme. This is true if I do it by the mean, and the next slide I have done that by the median. The median gives me slightly different results, but again, you can see that both for high and low performers, errors are decreasing in the tournament type setting. Okay? I'm going to skip most of that, so I'm going to wrap up, and I'm going to tell you what, if I have time, I'll talk a little bit about salary and salary values. But if I don't, then I'll skip. So, what do we find? Again, there are two huge intuitive jumps here. One is that if you think hard about this problem, you will get better, which is probably okay. The other is that the payment scheme has an impact on how hard you think. So the question then is that if the errors are smaller in a treatment, then the treatment is making a difference. So the overall finding is in this task, if you accept the validity of this task, it's a somewhat ill-defined task with no clear correct answer, the two best ways of paying people is a fixed salary and a salary that pays you on absolute performance but provides you the increased psychological information of winning or losing. Part of the reason why tournament-style payment schemes don't do very well is because people who are not good at the task do especially poorly in a tournament payment scheme. So if you want to pay people for performance, then just provide them with this additional win-lose information. That's good enough. Okay, I haven't seen this first bullet point. I'll get back to it if I have time. On the other hand, tournaments seem to do better if the task is really easy or very menial in some senses. Then maybe tournament-type tournament-type payoffs aren't bad. But I don't have a lot of data on that, so I won't think big thing. There's not a lot of learning across treatments, but it is the tournament-type payment scheme that seems to motivate learning over time. And this is mostly pronounced for the high performers, people who are good at this task. Okay. Let me skip this and I'll come back to it if I have time. So the question then is, what is your aim in some senses? If all you care about is minimizing aggregate errors, then a salary type payment scheme or a win-lose type payment scheme doesn't seem to do badly. In fact, if you believe that your worker pool is quite heterogeneous with different ability levels, then you're better off with these type of payment schemes. But if you can sort your workers, if you can sort workers into better or worse performers, then you might want to pay the better performers using a relative performance payment scheme. On the other hand, if what you're concerned about primarily is that people learn to get better over time, then you should probably have a tournament type payment scheme. Especially, so if you're a good tennis player, you should play tournaments. If you're a good golf player, you should play tournaments. But if your players aren't very good and you want to minimize errors, then you're better off just letting them pay the salary and not worry about it. I have 2 minutes left, and I'll tell you why that is true. Let me just back up. Now, most economists find this extremely surprising, that why does a salary treatment do well? Or how could it do well? That there is no incentive to perform, yet people are doing very well. Well, the psychologist's answer is that, well, in many of these cases, people are intrinsically motivated to perform. And if the task is challenging enough, if they think, well, it's, I really want to do well, not because of the money, but because I want to feel good about myself, then salary doesn't do bad. Here's another answer. I think one answer is that salary often reduces the pressure you feel to perform that you feel under some of these other treatment schemes. So let me just briefly talk about this paper by Merlo and Shorter, because you might find this interesting. So what happens in Merlo and Shorter is, let me just back up. I'm almost out of time. Is it okay to go a few minutes? Or if you have to leave, please leave. So what happens in Merlo and Shorter is this. I'll tell you what they have to do. So what happens in Merlo and Shorter's paper is people are confronted by a thing like this, right? So you know that you're facing a hill like this, and you have to find the peak of that hill. Except you have no idea where the peak is. It could be there, it could be here. So you can choose numbers between say 0 and 100 or something. And every time you choose a number, you get a payoff, which gives you some idea as to where that peak lies. That's all you know. That's the task. And then you have to kind of say, well, you know, what's the correct answer? Is it at 0? Is it at 5? Is it at 10? Etc. Etc. Right? And there are two different treatments. One, which they call learn while you earn. What's learn while you earn? You're playing this every round, and you get a small payment every round for how good or bad your prediction is. And they look at how people do. And then they have another treatment which they call learn before you earn. In learn before you earn, you play this for many rounds, and you don't earn any money for any of those rounds. Except at the end of, let's say, 50 rounds, you are then told that, look, you have played the game for 50 rounds, you have learned whatever you have learned, now you are going to play this, you're going to make one last prediction, and now you will get 50 times what these other guys earn per round. So if you earn, let's say, 50 cents per round, these guys will get 50 times 50 cents or something, right? And then they look at which group of people do a better job of predicting on that 50th attempt. Is it the people who earned a small amount every round, or is it the people who earned nothing every round? And they find the people who earned nothing every round, but who could kind of play around, did a far better job on their 50th prediction than the people who earned a small amount every round. And this brings me to my answer as to why the salary and salary win-lose. Why doesn't things work well when you get a fixed salary, but you... So when you get a fixed salary, but you also get this win-lose information, that didn't help. Things got far worse. People made bigger errors. Now, I don't have an answer, but here's a partial answer to this. The partial answer is, remember, when they're playing this game on the screen, they get to see what their errors were, and they get to see what they would have earned. Now, this earnings doesn't matter, but they still get to see this information, right? My conjecture is that when we went from a salary to a salary with this win-loss information, I think two things may have changed. One is people felt more control, right? In one sense, we told people, look, here's $20, do the best that you can. But then we tell them, okay, here's $20, but I'll also tell you whether you won or lost or did better or worse, and that didn't help. But what this is saying, what this is simply saying, is this on-screen information about earnings had a much bigger impact in the when we have the win-lose information than when it didn't. So it seemed when we provided the win-lose information, they started paying a lot more attention to what was on their screen round by round than thinking about the problem in a holistic sense. But that's all I can say at this point, right? So that's basically my story. That if you accept that this task represents some real life jobs, then it seems to me you need to think about, well, how heterogeneous are the people working for you? And if there is significant heterogeneity, then making payment based on relative performance is probably not the right incentives to provide. But if you can divide your people into sort of, high performers versus less high performers, or if you can divide people in skill levels, then for the high performers, you might want to pay them based on relative performance. So there's a Chinese proverb, right? The Chinese proverb says that when you're riding in like a bullock cart or an ox cart, then which bull do you whip the hardest? The fastest one. Because the fastest bull will drag everyone along with it. Right? So I don't know, I think this technique. I've been told that it's right. Okay, so as I said, so there are two different things here. One is Is it that you're trying to minimize? Is it just the errors? Or is it you want to learn over time? And that might also dictate what kind of payment scheme you choose. Okay, so that's my story. Now I'm done.
Thank you very much.
5 minutes over time. I'm happy to answer any questions.
Any questions?
Sure.
Very interesting. I think you have a lot of conclusions, and I have opportunity to read that already. Have you come?
Yes.
We've done recently a lot of work
That's right.
regarding the work and the incentives, and one main conclusion he found is the optimal level of stress level for people working, and that might answer most of your research, and he found that if you put a lot of stress on the task, and they will perform bad, and you have the real effort task for them that put the stress, I think halfway through the curve, and then you have the tournaments and something else. That means your sample is going down, so that might explain how they perform.
Sorry, let me say the last point first. How is the sample going down? The sample isn't going down, right? It's
No, the performance of the sample of your sample.
Sure, but okay. So let me address these questions one by one. So first of all, any job is going to come with some stress, right? There are no jobs that are stressless, right? All jobs will impose some level of stress on you. The question then is, what is more important? We are looking at the trade-offs, right? We want to provide incentives regardless of the stress level, right? So do the incentives overcome the stress effect, or do they not, right? Now, we do control for many of these things. There are different ways of doing that. We do control using psychological questionnaires. We control for things like this. So are you somebody who tends to get stressed very easily? That's what the trait anxiety controls for. You could do it in other ways also. A simple way of doing that is to measure what are called cortisol levels, which you can get from your scooter, if you want. That's not a huge issue in some senses. Ariely also has a paper where it's called large stakes and big mistakes, which says that when the stakes are large, we tend to make mistakes. That's all true. But that is also somewhat irrelevant to this story. Because what this does is it says, here's a task. And we keep expected earnings somewhat similar. But what we're looking for is changes in what matters. So when you go from piece rate to a tournament type payment scheme, so common hypothesis in economics is tournaments provide powerful incentives. But clearly it's not true always. Second, what we're asking is, if you say tournaments provide powerful incentives, why is that? Is it because the payment scheme is different? Or is it because the information is different? What do you get more pleasure out of? Making money or acquiring status? Dan really certainly hasn't looked at that, right? So what do you care about? Right? I have a lot of colleagues who will turn down more money to accept a higher rank. That's bizarre from an economic perspective. But I have a lot of colleagues who will say, I would rather have the higher rank at a different institution, if you don't give me the higher rank, than more money at this institution. That's a completely different story. Now, again, stress has a relationship with that. You know this, right? That rank, higher rank or lower rank, brings higher stress. Right? But that's a different question. That's not what we're asking here. What we're asking here is one level. If you went from absolute relative performance, what is it that seems to matter? And this seems to suggest that, well, that status concern seems to be quite powerful. The second question that Ariely isn't really answering, and not in his papers, is the fact that in this kind of a task, intrinsic motivation seems to be quite powerful. that if you pay people a salary, this would not be true. This would not be true if you asked people to do something like add up numbers. I don't know. I'm guessing. So what we are saying is reasonably different from the kinds of things that Ariely says. Again, you can tell me what specific study you're talking about, but the ones I'm aware of are the ones where he looks at people. Yes. So everything is related, right? This is a very broad area where you ask about how do you pay people. But bear in mind that all jobs will come with stress. The question is not the stress. The question is, what's the best way to get people to do better? And then also, how do you define better? What is it that you want to measure? What is your goal? Right? So if you were in a large hospital, I would say pay the doctors a salary, you'll be okay. Because on average, they'll do reasonably well. But if you worked at NASA and you wanted to make sure there were no errors, then don't pay them a salary. Pay them based on relative performance, because you don't care about the average error, you care about zero error. You want to get to a point where errors have been completely eliminated, because small errors can be catastrophic. Even in a hospital, it can be catastrophic. But what I'm saying is that, it can result in death. But I'm saying that it depends on the task and what you're dealing with. Right? So, at base, what this paper is saying is that, look, we know a lot of these things, right? But what we are claiming in this paper is that the basic concept that put people in a relative ranking payoff scheme, and that will be the best way to incentivize them, that is clearly not true. It's true in some cases, but in general. Now, obviously, these are very rudimentary experiments, right? So if you really wanted to do this, and you may have the resources to do this, you want to convince a company to try this out. Right? You want to try and approach a company, or you want to try and approach a hospital, and you want to do a randomized controlled trial, where you say, I'm going to take 50% of your nurses and put them on a salary, and I'll take other 50% and I'll put them on a small base salary, but then the rest of it will depend on how many errors they commit. And then you want to see what happens, right? So my suggestion is that maybe it might not make a big difference, but because those kinds of experiments are very difficult to run, you would be hard pressed to convince people to let you do these kinds of things with your workforce, right? But you could. There are people who do it. If you're interested, Ariely is certainly not. I mean, he is not the authority on this kind of work, except for his one paper on large stakes and big mistakes. So some of the references I provided, and then you want to look at a paper by Imran Rasool and Ariana Bandira on fruit pickers. So they ran a randomized control trial of this type on people who pick fruit, and they tried to understand which payment scheme does better. It's a slightly different question, not exactly what we are doing. But then you want to look at those kinds of papers that look at these randomized control trials where they actually go to an actual workforce. Now, what's the problem with that? The problem, or the advantage, disadvantage of doing this is very generic. So this allows me to say, well, if you concede that this task is a relative approximation of many jobs we do in life, because most jobs we do in life don't have clear-cut answers. So my job, for instance, says, well, I have to teach, I have to write papers, and I have to deal with a large number of people who all have different goals and aims and demands and things like that, right? And it's not very clear how you incentivize my task, because it requires very different skills. Now, you can do this in a hospital, but that will tell you what works in a hospital. But then, there's no guarantee that that will work for real estate agents, or it will work for car salespeople, or it will work for lawyers, right? Or it will work for investment bankers. So then you would have to run all these randomized controlled trials, one for doctors, one for investment bankers, whereas this kind of work, or another answer is you get doctors and investment bankers to come in and take part in this kind of task, which gives you some level of control over the task, and you try to see how they respond, right? This is more generic, but it's less real life. But the real life experiments are not very generic because you don't know whether it will translate. So something that works with doctors may not necessarily work with investment bankers. For investment bankers, what is your question? Your question is to get them to not take bad risks. Right? How do we incentivize that? Okay, I'll stop there. Okay.
I have some questions about the experiment.
Sure.
So, at the beginning, give each one 5 minutes to study an example, and then in each round, how much time you give? Like I participate in this
Right.
experiment, and then so I have to guess some numbers, right?
That's right.
How much time do you give? Am I given?
So think about this, every round you can earn $1, let's say. So over 20 rounds, you will get about $20.
No, I mean like how much time did you give me to make?
Oh, in each round?
Yeah,
In each round, we have about 90 seconds to 2 minutes to make your decision.
It's fixed, right? Or
No, it's not really fixed, no. There's no,
so I can take as long as I
you
want.
can take as long as you want, but we sort of say, well, after about 2 minutes or so, we'll say, could you please make a choice, right?
So what underlies this paper is that different incentive scheme leads to different efforts, right?
That's an assumption, yes, yes.
But
Yes, you have to buy that different incentive schemes are leading to.
But effort is not really explicit in this study.
No.
So, for example, I may measure the effort by the time it takes for me to make a decision, something like that.
Good
So
point. Yes.
it could be
Yes, that's a good point. It's not, first of all, it's not that clear. So in subsequent work, we actually have a timestamp on how long these people took. No, but that's not necessarily a good measure because it doesn't tell you a whole lot of timestamps. Because if you're good at it, you might be able to get the answer reasonably quickly after a while. But if you're not, you might take a long time. But you have a good point. So yes, the effort is not measured. So it's an assumption that smaller error means larger effort, but that's not.
which brings me to the second point. Sometimes it's not really clear how efforts leads to good performance in this kind of experiment.
Yes. Again, as I said, I don't know. What I'm saying is that I'm assuming that if the error is smaller, then that's a result of greater cognitive effort. Now, that may not be true, but that's an assumption. Because I cannot observe how much you're thinking. I'm assuming that if you're doing better, you are probably thinking harder about the problem, or you're probably thinking smarter about the problem. I don't know. I don't know what's going on inside you. I cannot really see you dig holes, right? I don't see you. So, but that's a problem in many tasks, right?
Yeah.
That measuring the output is quite difficult. So in tasks that with the in tasks where measuring the output is easy, it's not. These are difficult questions. You could devise piece rate schemes which says the more you sell, the more higher your payoff is. But the problem is that not all tasks are so easy to measure.
Yes, but in my opinion, I think the task you employ in this experiment, you cannot. I mean, the task itself is really simple.
No, it's not. No, it's not simple. It might appear simple to you. It's actually quite difficult.
No. I mean, it doesn't involve a lot of steps.
It involves a lot of steps.
If you know what the pattern is, then
No, but you don't know what the pattern is. Because what you're assuming, see, in asking this question, you're assuming, the first thing you're assuming is it's linear. It's not, you don't know that. So you don't know whether it's linear. Because if I tell you it's linear, then after the 4th round, there are only 4 unknowns. You should be able to solve this problem. Anyone with some skills, right? But you don't know that. So that's an assumption you have to make. Second, the fact that there's a random error term means even if you're exactly right, you still might be off because of the error term, right? So the task is not very easy. The second task is easier, but this is not easy in the sense that predicting the correct answer is not really easy. So I'm not sure what do you mean, because the Q values are, so one Q value in one round, I should have some screenshots. So you might get a Q values of, let's say, 20 and 50. This is very easy, because you know it's somewhere in between, right?
What I mean is
But when the Q values are very far away, it's not that easy.
I see your point, but what I'm trying to say is that in this kind of task, you cannot cognitive capacities, the mental capacities, and the efforts you have to put to perform whatever kind of thought process you are doing,
Sure.
get really mixed up. So
Could be.
for example, if I have tasks that require some mental capacities, there are uncertainty, but if you re-isolate it many times to get more accurate answer, that way you will know that effort leads to better performance.
Yes, sure. That's true here as well. Only in one treatment. Only in one treatment. Only in one treatment. There's only one incentive scheme that forces you to get better over time, which is a relative performance scheme. And that too is pronounced for people who are relatively good at this task. Again, I think you are underestimating the difficulty of the task. And second, you have to ask yourself the question, what other task could I use? So you have to then think about a counterfactual,
I
right?
have no
What
idea.
is, so what is it that I could use? So here are some examples, right? Examples are, so obviously you cannot get them to do differential calculus, right? That's not an option, right? So it has to be something that anyone can do. So here are some options people have tried, right? One option is adding up numbers in your head. You could, right? But adding up numbers in your head will never allow you to learn anything about learning, because either you'll get it right or you'll get it wrong. Then you could try solving mazes on screen. There's a maze and you have to solve it, as the more mazes you solve, etc. Right? What other people have tried is you go around, knock on doors and try to raise money for charity. Or you are given a whole bunch of library books, you have to catalog them without making any mistakes. So there are various different things, right? The challenge here was to get at a task which was difficult enough that it will allow you to see some learning, and yet a task that anybody walking into the lab can undertake without any prior training. Because you really cannot send out a whole bunch of people into the street and say, go raise some money, etc. Right? There are pros and cons to doing that. So there are a number of issues here. The question is, think about real life jobs. What do people do in real life? And most real life jobs aren't that well defined. So even car salesmen, for instance, have to do at least two different things. One, sell cars. But also two, talk to people who walk in who may not buy a car immediately, but might come back in a month's time and buy a car. So when you pay a commission to these people to sell a car, there is zero incentive to talk to someone who doesn't look like they're going to buy a car right now. Because what's your incentive? Nothing. Right? So even in a task that appears to be relatively simple, sell cars, there are at least two dimensions to this task. So as I said, the question then is, you have to come up with a generic level task. And go ahead.
But when I first see this experiment, I try to put myself into the test subject.
Sure.
So, and it's not, if I am the test subject, I don't know, it may not be that apparent to me that how my efforts would produce better performance. Sometimes I don't see it, especially when you have two cues.
That's not what we need, right? We don't really care about what the assumption is this. The assumption is that the way I pay you influences your thinking. Now you could say
efforts.
Your effort, that's right. The way I pay you. So again, there are some intuitive jumps here. One is, the smaller your error, the more money you will make. So based, if I'm paying you to make smaller errors, then you will think longer and harder about this. Now, that chain of reasoning may or may not work all the time. I can see that point. But that's a fundamental assumption in at least economics, that the way we pay people provides incentives for them to provide effort, right? Now, could it be something else? But that's what we do all the time, right? We say, well, if you do well, you will get a bonus. Or, if you do well, you'll get a promotion. These are all tournament-type payoff schemes, which says what happens to you depends on your relative performance, not your absolute performance. So, even if you publish a lot of papers, doesn't matter. What matters is whether you publish more papers than this other person. The question is that a good way of incentivizing people? So suppose I wanted to, I don't know, what is your goal here? Your goal is to bring in what? External grants, let's say. How do I motivate you to bring in more external grants? What should I do? What's a good incentive? So this is something I struggle with every day. I have lots of colleagues. My goal is to get them to write more papers and to go and do a good job of teaching in the classroom. And those two are not the same goals, right? Because if they go and do a better job in the classroom, that means they're spending less time writing papers. So it has to be optimal. So that's the question. The question is, suppose your goal is to bring in external grants, how do I motivate you? One way of motivating you might be that your salary is directly proportional to the grants you bring in. Right? It's a powerful goal. Right? But surely there are other things that you worry about. For instance, it could be that if you bring in grants related to Thailand's banking industry, that's a lot more money than trying to figure out how to get a decent education into Thai children. So if it all depends on the money you bring in, you'll be going after the bankers. You're not going to spend any time worrying about the kids.
There's this incentive scheme which motivate more efforts would only work if I believe, if I think, if I see that by putting more effort will bring better performance. If I don't think that way, all the incentive doesn't matter. So here's the thing. High performers may have thought process that leads them to enable them to learn, right? So effort means something to them. But if I have blank, I have no idea what is going on, then I don't know how my effort could be used, right?
Good point. But in some sense, that's what we're trying to understand here. Because we have these treatments going from one to the other, we can address some of these questions. So that's an excellent point. You are saying that to how does my effort translate into payoff? Now, obviously,
It's very explicit, implicit at this point.
no, it's in a tournament scheme, it's very explicit. You do better, you make money. You don't do better, you get nothing. It's quite explicit.
No, you get more money by guessing more accurately. You don't get more money by putting more efforts.
But those two things are synonymous. You have to, unless you concede that point, then it's very difficult to argue this anymore. Those two things are assumed to be synonymous, that if you are making smaller errors, you are putting in more effort. Otherwise, if you claim that you are making smaller errors randomly, then I don't really have a good, if that's what you believe, then I don't really have a whole lot to say. Possible. What I'm saying is that smaller errors, to me, immediately implies greater cognitive effort, because I assume that the only way to make smaller errors in this problem is if you're thinking hard about this problem. If you're not thinking hard, the chances of you doing well is small. That may not be true, but that's my operating assumption. So in some of these cases, the payoffs are explicit. You could make the argument, I don't know if you're making it, which some people make, that the stakes aren't large enough.
That's not mine.
Okay. Now, I think the stakes are, that argument usually doesn't work around because the stakes are probably good enough, right? So in some of these, the stakes are quite explicit. Right? And so you can see how your effort is getting expressed in smaller areas.
Okay, let's leave it.
No, sure. These are all valid questions.
I think I could make a good point between what you're saying, because TDI at this moment, we are in a phase of looking at this point also. Like we said, over here people have a salary.
Right.
They have a salary. The problem with, like you said, what is our objective? Our objective for some people is to bring in funds, grants. But for most of us here sitting here, their objective is to do quality research in policy research. But the problem with researchers here, a lot of them, they don't even know what is expected of them. But a lot of people here come here because of intrinsic motivation.
Sure.
Public-mindedness.
Sure.
But we're not providing them with that motivation. They come in with a certain intrinsic in themselves. They come here because they're public-minded, they want to help society. But we are lacking the mechanisms for intrinsic motivation. We lack a recognition system. We lack an achievement system. We lack a system where, assessment system. So this is very interesting because I like to ask everybody here, what kind of incentive would you like? Would you like a salary? Would you like a salary? Would you like piece rate? Because my doctors, we do piece rate.
That's right. Yes.
We do piece rate. But my nurses, we do salary plus piece rate. It's many. It's all. I think it comes with the role. The role often defines what kind of incentive works well, because the role, people come with a a reason in life to work. People here, I think, Dr. Chaudhuri, they come here because they want to make the world a better place. So if I give them piece rate, they're not gonna do it. It's not gonna motivate them.
No, sure.
Yeah.
Do you have a question, sorry? Do you have a question or?
I just feel like if we have a very small incentive, like piece rate in VDI, so why would we put a lot of effort for that? I mean, even though it's very small amount of money, I add extra for our salary, which is all the same as we are doing or have been doing such. So, but it's very interesting to me because it more assess individual. Do this person get promoted or not? In terms of if they can minimize their errors. I mean we cannot assess and compare higher performance and lower performance. In this sense, I think individualism is more apply for this. I mean,
Sure. No, all I'm saying again, if you assume that the task itself has meaning, let's say that you concede that, okay, this is a good way to look at some real life job. But what I'm saying, it seems to me, and to be honest with you, this is not what I do. I just got into doing this with these colleagues of mine from UC Northside who have done more on this kind of, both from a psychological economic perspective. But we are now, this is a large amount of data. It seems to me that the first question you have to ask yourself is, do we want to use a performance-dependent payment scheme or a payment scheme that is independent of performance? We might have good reasons to do that. Now, if you decide to have a performance-dependent payment scheme, then a common precept in economics is that you should rely on these tournament-type schemes that reward people for relative performance. So there's a huge literature which says that these tournament-type schemes provide very powerful incentives. But what this is saying, and this is not the only paper, as this gentleman pointed out, the other people also looked at this, is that tournaments are not always a good idea, because it's not good for everyone. It's probably good for some people, it's probably not good for some other people. So if you want to pay up people based on performance, then this suggests that pay them based on absolute performance, but maybe provide them the psychological boost of doing better or worse. But then switching over to a payment scheme that pays them based on doing better or worse doesn't seem to be a good way to do it, because the ones who are not good tend to give up very quick. Their errors, their performance drops quite sharply, because they begin to understand that I'm not getting this. Right? So, and there are a number of offshoots of this. I don't know how much time you want to spend. I could stand here and talk for hours, but one argument in all countries is that if you go to the United States, there's all this discussion about, young blacks. Why is it that they give up? There's this paper I wrote in Fire called The Economics of Acting White. And here's an answer to this. The answer is that even if you take two people who are relatively close and you put them in a tournament called life, where the winners get a lot of benefits and small losses lead to bad outcomes, the losers will quickly give up very, very soon. Right? So that's one answer to why tournament type schemes within the workplace may not necessarily get you the best outcomes.
I think.
Besides the question of the stress that it creates.
Yeah, and also like the other variables like working experiences or education that they have before, some people might like get easier to solve.
Sure.
And other factors
No,
affect
so assuming
as
that
well,
all
like-
those things are constant, even if you hold all those things constant,
Mhm.
small differences in relative payment schemes, relative ranking schemes, small differences may create large winners and losers after a while. Because the losers, after a while, they're not going to try very hard. So for the organization as a whole, that may not necessarily be the best thing to do.
And I also think like many organizations in Thailand or also other countries as well, like doing this for such select employers before like get into the company. I think there's like, for example, we have test again before we get into such companies.
Sure,
So
if you can
this-
sort your workers before
Yeah.
they start working, and
Yeah.
you make sure that you take only the dollar cream, then you have a different problem on your hands, right? That's a different question. So this is a question of, let's say, selective private schools versus a public school which has to take in everyone, right? There's a-
I just like it came from the same basis idea, like how to select people or get people to promote, like give promotion to that people.
Sure.
Yeah, thank
You know,
you.
I'd like to answer something that you said. You know, excuse me, Dr.
Sure, no, please go ahead.
You know, a lot of people think that in TDRI, we try to recruit the people with, like, say, the most knowledge, you know, very, very knowledgeable and stuff like that. But actually, we are trying to recruit the person who has basic knowledge, but a very high ability to learn. And we are trying to, that's why the model that we are doing, we're doing what we call a competence guideline. We actually we don't want to discriminate between, each person starts at a different point, right? But our point is that we just want to see that we tell you this is the competence that we expect in the future for you to go towards. And even if you start at a different line, you're progressing on your own. And the other person can progress on his own. But the point is you get to the point where your competence is at a certain level where we believe that that is your skill that will reflect on the output of your work and the institution's work. That's what we're trying to do. So I don't know if I help.
Yeah, I understand that. But I just like speak what I think now.
I understand.
So I understand the like competence
I
model
have
and
one
like.
question. I guess this would be the last question since we're running out of
Yes.
time. So you think in the tournament treatment, if you punish people that do badly, do you think that they will try to put more effort in? So instead of just, let's say, they just get 0, I'll just give up. Doesn't matter. I just want this game to be over quickly, right? Because I'm saving time. I want to go home, have dinner.
Could be.
And instead, you just punish them. Okay, you try harder, so you create a little bit more of a competition there.
Yeah, it could be. I don't know. I don't know if. One answer would be to make it easier. So winner take all tournaments are quite difficult, right? Because you keep getting zeros. Whereas you could look at what are called rank order tournaments, right? We put people in groups of 4, and the first person gets a large payoff, and the second person gets a little smaller payoff, etc. So those are more forgiving tournaments in some senses. But I don't know the answer to that. But certainly in this case, people who after a while, some people are not performing so well in the tournament type payoff because they're not quite getting, they don't know that they're not getting the answer in some sense.
But if you compare the low performers in tournament payoff and low performers in maybe salary or history, maybe you can say something about
Good question, good point.
their efforts. Because if you compare those two treatments, let's say it would answer the questions basically, do you put effort in or you just basically don't know the answer. So if you compare those two treatments, then maybe you can get some.
I see. Okay, I can look at. So we looked at a lot of these kinds of things to see if there was something there. But maybe I should look at that. I'll look at that. Well, I'll ask Tony to look at that when I get back. Tony's my PhD student who will do all the looking.
I actually did this. I helped you run one of the sessions with Tony.
Right.
Just to confirm, the task is really difficult.
Okay.
Okay.
Thank you very much.